I think we should be good with recording. So, like I said, this is the week 2 and our Wednesday morning session. And just in the interest of time, I want to be very respectful about the fact that you have places to be and things to do. So I'll try to stick to the timeline that we have kind of put aside. Just a quick note before we make too much of a start. With the objectives that I kind of set for this meeting, I want to show you, and I'm going to jump out of this screen to share with you my actual screen. So you should be able to see my Chrome view, and over there I hope also the modules. If I jump to the student view, so it aligns a little bit better with what you probably would see on your screen normally. Let's get that running. When you go to modules, you would see something like this. And on this week's module, we're focusing on the endocrine system. And you might see that there's this handout, endocrine glands and diagrams. So I'm not saying that that necessarily is the way that's the best way for you, but some students find it useful as we do this review session to kind of have that on hand if you're a little bit uncertain about the major endocrine organs. If you know them, you're all set. But that might be something that you might, for example, download on your files or give it a print or just a draft, a quick diagram. We will use it a little bit later on, not immediately here, but that's something that you might consider that might come in handy on today's review when we go through the main points of the endocrine system. Of course, we won't be able to cover everything about everything, but I want to highlight what are the main points, what are the things that I would be looking for when we get to the test time. I know that that's what students are really kind of what their mind is set on. So I want to make sure that you have all the tools and all the resources that you need to succeed. And on that note, do remember that all of my tests, all of my exams, all of my practicals are open book. So doing good notes now might be helpful for when you are taking the test. So I'm just putting it out there in the universe that if you feel that it is something that helps you to make good notes, have those that you can refer to. So that's one option. What's important for me is that you're not going to be super stressed about the exams. You're not going to be super stressed about all that. So many students find that that eliminates a little bit of stress when they have their material in front of them. So I'm not really wanting to bother you with having to memorize minute facts for the exam portion. I'm just wanting you to have a general idea what goes on, and from that being able to deduct the key points. For the practical exam, once we get to that, there is going to be some more minute stuff. It is simply what the name says, anatomy, some histology, some smaller structures, some structures within structures. So for that, again, remember, you can use your notes. I encourage you to take good notes. So just throwing that out there. So you'll find this diagram that I showed you within the weekly material. And that one was under the heading handout endocrine glands diagram. So we'll use it a little bit later. You might also see, if you were really super observant, that I just this morning uploaded an announcement or posted an announcement about that might come in handy on this session. But what I'm gonna do, I'm gonna jump back to our presentation. That was kind of a little bit of a outside what I wanted to say. And we'll continue where we kind of dropped off. I think we were here. And remember, at any stage, feel free to shout out if you have any questions. I'll try to keep monitoring the chat. Sometimes that things might sneak out because the software kind of pushes it to the back. But then just turn on the mic, give me a shout out. We'll have time at the end also for the review of any questions. But I just want to make sure that you don't at any stage have to hold on to the question. When questions come, just let me know. So what I wanted to do as the very first thing, I wanted to thank this class and especially you two for showing up this morning. But in general, this class, you guys have been probably the most organized that I've ever seen, because what happens during the first week is that if we have students who don't complete activities, who don't take part, we actually have to drop them from the class. And not a single student was dropped from this class. So I'm very, very impressed and very proud of you. What we should have completed so far, so during the last week before the Sunday, was the syllabus quiz. And I think that I saw syllabus quiz also from everyone. I've manually gone. There was I think a signature part at the very end that I had to manually give you points for. So if you did all that, you should have 4 points already in your pocket. And then there was the introduction, discussion, icebreaker, some really good comments there. I'm going to participate a little bit more there, so you'll see a few responses coming from me. Sometimes I do get questions that how to succeed the very best in these courses. And one thing that I do say that is, if it's an online course, really what we're testing is your ability to stay on top of the workload. So I really encourage you to just try to do that. The other thing, when I think of back on a little bit more advanced university level courses that I've thought that what are the things that some of the most successful classes did? Well, remember that you're not in a competition with each other. For all I care, if everyone does amazing, everyone can get an A. Of course, I'm not just gonna give the A for the fact that I like you all, and that's the only reason. You do have to learn something during this course. But one thing that some of my classes have done, they have taken notes and shared notes with each other. They have formed small study groups if you feel that that would help you. So having that help from your classmates is definitely something that I encourage you to do. I've seen very good student approaches where they, for example, done a Google Docs note page where one person is taking notes of the group every session, and that turn rotates, but others chip in and fill in if that person misses out on something. So just throwing out ideas, whatever works for you. But remember, all the notes, everything that you can make notes of material is things that you can use in the exam. And sorry about the screaming. I've got one very upset cat here. We're actually snowed in. So I don't know if I mentioned, I live on a foothills of Mount Lemmon, closer to Tucson. So we're physically snowed in. So she's not very impressed about that. Other thing that I wanted to say about the small groups and peer things, if you ever need someone to facilitate it or help you, I'm more than happy to do that as well. I'm more than happy to meet you in person or virtually, but one-on-one or a small group. So just let me know where I can help. Quick, just a couple of words about these weekly sessions. So you can attend in the live format. I think that the word in person might not be ideal there, but you can attend live immediately when these are happening, like you two do, or then if you're unable to attend, the recordings are of course something that's also available. So I do record all of these sessions. So that's something that just be aware of, that's another tool for you to make sure that you get the material. These take place almost without exception on the Wednesdays in the morning and then in the evening. Remember that it's the same material, so you don't need to attend both. If you don't feel like it, of course, you're more than welcome, or you don't need to attend to either one. What I'm going to do on this is not really introduce new material. All the material that you need to know for the exam is in the Canvas already, but I want to highlight the key points. What's worth of knowing from this chapter that we look at each week, and especially make time for the questions and answers. This week, what I'm asking you to do is going to be 4 pieces of assignments that count towards your final score. So it's going to be 25 points up for grabs this week. There's going to be the Learn Smart, which is when you log in to the McGraw-Hill Connect. It's basically questions from this chapter with a link that you can pull up that very question section from the electronic textbook that you have. And if you answer to all of those, you will automatically get 100% for that. So you will get that 5 points. And even if you miss a question, the question will just come up again. So there's nothing to be worried about that. Quiz is also included. That's a traditional quiz about the content of the chapter. There's a little bit of more physiology. So we will be looking at one endocrine gland on this week's lab, which is going to be the thyroid gland. And then there's those anatomical structures, which is the practice anatomy. And remember that the practical, which is on the same week as the exams, is about these practice anatomy videos or sections or activities. So that's something to bear in mind. If anyone is having hard time accessing the Connect, I would not think that that would be unusual or something that you should be embarrassed. Just let me know and I'll help you. Have a look of the materials that are on the canvas as well. It is something that we'll use quite a lot. So I really, really recommend that you have a look of making sure that you're able to access that. There's also a lot of additional resources that I can provide if you're having trouble with any content or getting the Connect working. And I'm also happy to meet with you if you want to get set up with Connect and it's not working out for you. I've received a few questions from students that are their study guides. I find that very American thing, and I'm not saying that it's a bad thing. I'm not necessarily not used to providing study guides, but I have heard you and I will definitely do that. And by no means don't think that I'm a super religious person. I actually am not, but I took that quote since I thought that it was a good fit. So for the study guide for this week, if you feel that that would help you, I'm gonna again jump out from here and show you on the Canvas course. So let's jump back to the student view. So you should be seeing my screen as if I was a student. When you go to the modules and on this week, there is the study guide for the endocrine system. What it does, it lists in a very brief bullet point format the structures, major endocrine glands that you need to know, and then the major hormones that you might want to make a note. Do you have to remember these by heart? No, remember that you've got your notes available for you in the exam. But that kind of helps you to guide if you feel that, oh, did I get everything that I needed to get out of this? So study guide is there. Don't feel that that's the only way to learn. But since students seem to like those here in America, I'm more than happy to put those forward. And again, sorry, I'm jumping back and forth. Let's go to our material for this session. So what's the next step? What I want to do with you? I want to go through the key points of this week's material. And like I said, we won't have a chance to go through everything, every single slide that you would see on those lecture videos that I posted there. But if there was anything that was unclear or you might be a little bit uncertain that what on earth did I refer with that, this is the time to cover those. So I want us to spend most of our time focusing on the actual glands that make the endocrine system and making kind of a little bit of a cheat sheet or hand manual that you can use to refer that what's the function of each one. And this is where this handout that I posted as a blank one might come in handy. So we'll use this to guide us on that process. So what I'm going to do, I'm going to change our presentation to another one that I want to share with you. So what I'm gonna put up, and you should be able to see, is that very same diagram that I just shared with you. Again, if at any stage you're not seeing something that you expect that you should be seeing, just let me know. I'll try to monitor the chat, but like I said, it sometimes fades away, so don't hesitate also to turn on your mic. So what we see here is a diagram of a human body. And again, I think that the anatomical terminology is really important. This is almost perfect diagram. It is as a person in an anatomical position, with the exception that the head is tilted on the side. And we have done that tilting of the head to the side so that we can actually see the mid-sagittal view of the brain. So we can see structures in the middle of the brain and brain stem. So that's the only deviation from that. So we're looking at from the anterior side, the face then is facing anteriorly towards that direction. And we've only listed the glands that relate to the endocrine system. So like I mentioned in the introduction or in the videos that you had for this week's material, I think you finished your last BIO201 course with the nervous system. And there we saw the nervous system was super fast, but also very short-lasting signals that were being sent through that. Endocrine system is the second way how we can pass messages in addition to the nervous system, but this differs from the nervous system in a way that it is very slow to act in comparison. But also the messages that remain then, or that are sent, they remain for a long time. So it's a long-lasting messages that are sent. So you can think of, for example, endocrine system being the method how drugs would work in your body. So we put a chemical into your body, it travels everywhere. It takes a while to travel that way, but it will also remain around affecting you. So very few drugs get cleaned off from your body immediately. So if you're still kind of struggling with this concept, one way I've explained it to the students in the past is that if you think of a condition of having an epilepsy, epilepsy is basically nothing else but part of your brain starting to fire signals, and those signals are uncontrolled and they just start spreading everywhere in your brain, and they don't contribute necessarily to anything positive. So it's just a misfiring that then takes over and spreads and spreads. So that's an example of the nervous system signals. They're quick, they're acting very, very fast, but they also last for a short time. Once those signals stop firing, the epileptic seizure, for example, might be over. How we treat epilepsy, there's many ways, but one of the more common approaches these days would be through drugs. Well, drugs take a while to get to the body. They circulate within the blood. They're everywhere, but they also are going to stick around. So that's why you need to have a stable level of drugs in your body at all times. And for example, those drugs would be very, very successful these days in management of epilepsy. So I think that that's a good kind of intro. There is a theme that I encourage you to be very familiar with, the homeostasis. So I don't know how much you have covered of homeostasis in your intro classes, in your BIO201, but it is one of those themes that keeps coming up time and time and time again. So actually, before jumping to this diagram, I do want to highlight that. Ooh, I don't know what I did. I'm gonna jump to just to the actual lecture slides that we've had a look and just highlight that portion of those. So I do ask questions about homeostasis as basic concept as it is, but I ask that because it really is a core concept that we keep running into time and time again, and multiple times even during this this course that we'll be covering So let me just open up the slides for that. So when we talk about homeostasis, and you should be able to see the slides that look fairly familiar from the lecture material that you have covered before. One thing that we keep running is this concept of homeostasis and how it really applies to everything in the human body. And many times students do a good job of providing a definition. The definition can vary a little bit, but it's all about securing that the internal conditions inside our body are maintained constant, so they don't deviate. We want to have as much of a consistent, stable situation as we can have. Oh, let me just set up that. The problem with these slides is that they keep moving. So this is what I've used as an explanation of homeostasis. So what happens in homeostasis? So what triggers a homeostatic mechanism or homeostatic feedback loop is when something changes. So let's say that we take an example of, since it's a cold day here, snow day, your internal body temperature starts to get colder than it should be. What happens? Let's look that through a process of homeostasis. So there is a stimulus, and the stimulus would be that now our normal core temperature of the body, which is around 37 Celsius, I would have to look up what's that in Fahrenheit. The rest of the science uses Celsius. That deviates from that. We're getting colder than we should be. And what we do there is that we have some sort of a sensor. In this case, it would be the thermoreceptors, both inside your body, also on the skin you have thermoreceptors. We notice that it is getting colder than it should be normally. And how we notice that is through a sensor passing a message to the control center. But remember that sensor alone really doesn't do anything with the information that it collects. That information needs to be processed. And where it normally gets processed is, of course, within the brain. So brain is typically our control center. And if we have this range of what's the normal body temperature, we also tend to have a set point that gives us the lowest temperature of the body, for example, that we still consider acceptable, and it gives us the highest temperature of the body that we consider acceptable. So here we would be moving somewhere around 36, 35 to 38, 39 range in Celsius degrees. If it's anything lower or above that, you will react. And how we react to that is through an effector. So some sort of a response gets taken. How I explain this to students often is that consider this example of temperatures as if your AC unit on the wall. You have that little box where you set the numbers or set the temperature that you're aiming. If it's any lower, if it's any higher, that will kick off the actual AC machinery to act on. So I hope that clarifies a little bit the concept of homeostasis. But if anything, I want you to take away the message that the point of the homeostatic feedback mechanism loop is normally to stop this stimulus from happening. So we want to keep the consistency. And this stopping it happens then through the effector. And this is known as negative feedback. So most processes in the body are all about using the negative feedback to maintain homeostasis in the body. There's only a couple of instances where we would see positive feedback, and the instances that I can think of would be during childbirth, when you're when the baby has turned around, the head is facing downwards, pushing to the uterine wall lining, and that causes stretch on the uterus. And that stretch is detected by sensors and passes a message to the brain telling us that, okay, now the baby is gonna come. It's pushing that uterine wall lining. There's no longer coming back. So we can no longer just cancel that. So for that reason, the effect that we will have will this time be positive. So we make the stimulus happen even more than it was happening before. In that case, it would be the muscles of the uterus and elsewhere contracting, helping us to push the baby out. So that's the one of very few examples where positive feedback takes place. Another one is forming of a scab, clotting in the blood, that once you start to form it, that promotes more of forming it to the site. That makes sense if we have a cut and we are starting to form a clot on that, we want to keep it doing until it's fully covered. I think there's a third example which I cannot think of from the top of my head at the moment. But remember that most of the time we are seeing the negative feedback as what the homeostatic feedback mechanism loop does. So this was jumping a little bit off from, it's not off from material, but it's off from what I wanted us to focus on. So what I will do, I will once again jump to another slide. And here we have where we were just before. So nothing has changed, nothing's too dramatically different. And what I want us to do is that we're going to go through all of these glands that we can see here. So endocrine glands, endocrinology, endocrine was all about hormones. So let's see what these glands that produce hormones are and what hormones they produce and how these hormones act, as a kind of a quick run through of what's going on. So as we are discussing these, we're just simply going to use this handout. In your lecture material videos, there's a little bit more pictures. I've tried to make it a little bit more entertaining, but I'm sure we can make this work even with just this, keeping it basic for the purposes of making it as easy as possible to follow. So I want to start with the hypothalamus. And we've seen hypothalamus before, I believe, when you covered the nervous system as part of the BIO201. I believe that it's one of the final concepts there. So let's have a look what we can remember of the hypothalamus and add a little bit more new content as well, so we can be certain that we know everything of hypothalamus as it relates to the hormones and hormonal system. So hypothalamus is often described as, sorry, I'm a guy, I can't do two things at the same time. Chewing gum and walking is too much. I have to stop and do the chewing. No, I'm just kidding. But hypothalamus is often described as the master gland of the endocrine system. Well, basically, it does what the name suggests in terms of being master gland. It controls what other glands do. So it is really overseeing a lot of these other glands, what they can do, how they can act on things. So you can consider it either as a master gland or a gatekeeper or whatever term you wish to use. But you'll see that that's often assigned to that. So how hypothalamus works is that it actually sends signals, and we're going to have a look of the second one, which is going to be our pituitary gland. And let's use that as an example. And I'm going to use different color for that as well. And you remember that pituitary gland was immediately underneath the hypothalamus, this kind of a hanging pair of sacs. So this gland had both anterior and posterior part to it. So we're going to work with that information. And we remember that the signals that we received from the hypothalamus normally act on the posterior lobe of the pituitary gland. And let's see if we can make this a little nicer. That looks good to me. So what I'm wanting to do with this is simply to show that being this master gland, the hypothalamus now sends a signal to the pituitary gland, and especially the posterior lobe there. And this posterior lobe then, later on, conveys these messages to the anterior lobe. So we're getting kind of this passageway of signals nicely here for us to appreciate. So this is all I'm trying to tell with these arrows. And at any stage, if they don't make sense for you, you definitely don't have to think of it the same way as I do. I just find it easier considering this way. So hypothalamus, the master gland, oversees everything, sends a signal to the posterior pituitary, which then can act on the anterior pituitary. And what we really should look at is some of the ways or some of the hormones secreted from the posterior portion of the pituitary gland. So there's two important ones. The first one is going to be oxytocin. And oxytocin is involved especially with the birth and lactation. So on the delivery of the child and also milk production. So that's what oxytocin is especially, or what oxytocin acts on. Another hormone secreted from the posterior pituitary is going to be ADH. And ADH stands for anti-diuretic hormone. I'm just trying to zoom in closer in case I realize that that might look too small for you guys. I really do try to follow the chat, but that always just disappears from the view when I do something here. So ADH, as the name proposes, is anti-diuretic hormone. So what it does, it helps us to control urination, and how it does this is by bringing the urination down. So it's against of doing something. It makes us produce less pee, less urine. So those two are the important hormones of the posterior pituitary gland. Oxytocin involved with the lactation, involved with the delivery of the child, controlling the process of birth, and then the ADH, which was all about reducing the production of the urine. And then we should look at the hormones from the anterior pituitary gland. And there's going to be more from here, so don't let that throw you off. We'll keep it simple. The first one is often abbreviated as GH. That stands for growth hormone. So growth hormone does what the name proposes. It promotes our growth as part of the development, promotes growth of different body parts, promotes our growth in overall. Another hormone there that I want to mention, and I'm just wanting to take the bold away, is going to be our adrenal hormone. So adrenal hormone is also secreted from the anterior pituitary gland. And we'll talk about that a little more later on this course, but at this point, as long as you know that that's secreted from there, you're in a good place. Two other hormones, or let's do actually first, two other hormones that we need to know from the anterior pituitary are going to be our FSH and LH. And these will become very familiar when we have a look of the reproductive systems. So even if they sound now kind of vague, we will come back to them at the very end of our course. So FSH stands for follicle stimulating hormone. So it stimulates the growth of the follicle, which will then become, for example, the egg cell that the female ovary releases. So that is a hormone that kind of promotes that development process of making a functional egg. And this egg is, we only do one egg at the time. So that's controlled from the anterior pituitary gland through this hormone. LH stands for luteinizing hormone, which is actually more involved with the triggering the ovulation, release of the egg. So it also plays an important role in especially for control of the female menstrual cycle. We'll see the follicle stimulating hormone and luteinizing hormone also in the male system, but I'll leave that discussion for the time when we get to the end of the semester. Another one that I do want to mention here for the anterior pituitary is going to be abbreviated as TSH. TSH stands for thyroid stimulating hormone. And if you have this in a different order than I do not worry. There's really no right or wrong way to do this. I'm just listing them as they come to my mind as a level of importance. So TSH, standing for thyroid stimulating hormone, it controls the release of hormones from our thyroid gland. And we'll have a look at the thyroid gland as the next one. So again, you can see that there is this process of steps. Hypothalamus controlling posterior pituitary, which controls anterior pituitary, which then through thyroid stimulating hormone controls the thyroid gland. So it's this chain of commands that takes place in the hormonal system control. And the last hormone that I want to add here to the anterior pituitary is going to be prolactin. So prolactin does what the name would make you think. It promotes the lactation, so the production of the milk. So that's another important one. Now in neonatal life of the newborn and after mother has given birth. So another important hormone that we'll see playing on to the reproductive system chapters. So now we have covered two of the big ones. Hypothalamus oversees everything, and how it does that is typically through the pituitary gland, and most often through the anterior pituitary gland hormones. Whereas the posterior pituitary gland had only two important hormones that it directly secreted that I wanted us to be concerned of. And in case you are kind of wondering, how does this connection between the hypothalamus and pituitary happen? You might remember that you have sometimes seen a term like this, infundibulum. Infundibulum is an anatomical term that we use simply for a connection between two parts. And in this case, it's going to be this kind of, wonder if I can draw here. I think I should be able to. If we think of the hypothalamus, oh, I was hoping that it. If we think of the hypothalamus as a structure being, oh well, this will work. Structure being right on top of the pituitary gland. These two connect then. And I'm just trying to, sorry, it's taking me a second to get that a little bit more presentable, my scribble drawing. So how do I can do it with this, I think. So what I've done is a side view here of the hypothalamus and pituitary. So for the sake of clarity, I'm adding here. If the software allows me, I would have added, oh well, not quite sure why I'm not allowed to draw here. One more try. So anyways, what you would see here at the top would be our hypothalamus. It's almost like I've been banned from doing anything on the... Oh, that's a shame. I'm just simply gonna let you imagine the colors since I can't add these on this diagram of mine. At the top, we've got the hypothalamus. At the bottom, we've got our pituitary gland with its two lobes. And between those is the infundibulum, this stalk that connects the two. Well, this brings us to talk now about the thyroid gland. I would have really liked to continue on this handout, but I'm completely frozen. So this happens sometimes that technology is not on our favor. So we'll get this sorted. It might just be that I've got too much going on at the same time. Sorry about that. I'm gonna open the drawing again. Now you should be seeing the same view again that we were looking earlier on. And we can see nicely that diagram that I added there about the hypothalamus and the pituitary gland. That's better. So there we have our hypothalamus at the top, and we're gonna add the pituitary gland with its 2 lobes here to the bottom as a color coding as well, in case that is something that you find helpful when you're trying to make sense what that scribble was. The structure between the two was, of course, our infundibulum. I'm just going to use a different color to highlight that. Well, that was extremely laborsome for a little thing, but we got there in the end. And we're ready to have a look of the thyroid gland. Well, thyroid gland is the gland located kind of at the neck on top of our thyroid cartilage. And thyroid cartilage then had this prominent feature of the Adam's apple, so pharyngeal prominence. So that might be kind of helping you to locate that. And what I want to do here, I want to highlight that the thyroid is really involved with the regulating the metabolism. So metabolic rate of an individual. Through, let's get the color here. Oh, I didn't mean to do that. This has been a little bit of more of a hot mess than I anticipated. So thyroid gland issues can be associated with the trouble with the metabolism. So for example, overactive, in which case we would not be able to gain weight, we would not be able to put on weight, even if the patient is eating, doing everything right in that. Or underactive thyroid gland, then that you gain a lot of weight, even though you basically don't eat hardly anything. So thyroid gland can be an issue behind that, but it's not always the definite issue. But that's something that we check. Within the thyroid gland, we end up seeing there's small dots there. And these small dots that we see within the thyroid gland, I hope I didn't move too fast. I'll go back there a little bit so you're able to see. These small dots are known as parathyroid. So parathyroid really does a bunch of things. And I'm going to just change the color again. I'm trying to get a color that we wouldn't have used a lot before. There's a few things that's going on here. This looks better. So what parathyroid do is they play a significant role in calcium regulation. And as you'll notice later on this course, calcium is really involved in pretty much everything in the body, from passage or enabling us to have a nervous system passing messages, but to pretty much every other process. So calcium is all over there, and parathyroid plays an important role in regulation of that. Other things that we can associate with parathyroid, regulation of the kidneys and urine production. So plays an important role there, and also in the regulating the intestines. and through intestines, of course, the regulation of also digestion. A few other things, I think that with the calcium, it kind of makes sense. Parathyroid plays a major role in regulation, controlling the development of the skeleton. And final one that I would add here is gonna be vitamin D activation. So parathyroid plays role also on that. So if we have issues with any of those, parathyroid gland hormones might be an explanation behind that. And we saw those parathyroid thyroids were those little dots within the thyroid gland. The next one that I want to show is actually a tiny gland within the brain, and that's the last gland of the brain that I want to highlight. That's going to be our pineal gland. And what pineal gland does, and I'm going to give it a different color, it does produce something known as melatonin. And you might have heard melatonin before. Normally when I ask from students, where do we have melatonin? What does it do? If they've just had a look of the skin chapter, they might confuse it with melanin. It has nothing to do with melanin, but melatonin is all about the sleep and wake cycle regulation. So if you have, for example, issues with falling asleep, one thing that you might end up doing or being told to do is to take some melatonin. It helps you to kind of adjust this range that when should you be awake, when should you be asleep. Also, people who travel a lot of transatlantic travel, or even here within the America from coast to coast, might need to adjust their sleeping patterns because of the time zone differences. So melatonin could be a supplement that we use there as well for. Next gland that I want to mention is actually underneath the thyroid gland, and this is a weird gland. We don't really see it as a very prominent gland in adults. It's larger in children and then shrinks over the age. And this is our thymus. And what thymus does, it's going to be especially important in production of the T cells. And we'll talk about T cells and all about that when we talk about our immune system. So you might notice that a lot of people are now talking a lot about the immune system with the COVID pandemic and vaccinations and all that. So there's two main cell types that play a role in the immune system, B cells and T cells, and we'll have a look of those later on this course. But all you need to know at this point is that thymus produces, or is the site of maturation of the T cells, and the thymus is less prominent when you get older, so it shrinks. When I work on catheters that people, I rarely see it as a structure that I can point out in older people. It's only in the very young ones where I'm able to point that out. So our listing of the glands and hormones that they produce is starting to take shape. I think it's looking pretty good, but we're going to get to probably to the busiest one of all of them. And I'm aware that we're kind of pushing it with the time. So if you have to go, there will be a recording available, but I'm going to try to wrap up real quickly. So we're going to have a look of the adrenal gland. And let's get a good color so it shows up. It's a little pale for my liking. Let's use this. So let's have a look of the adrenal gland. Adrenal gland is a small kind of, if you think, a pyramid-shaped addition on top of the kidneys on each one. And what we're going to be doing with the adrenal gland, that we're going to be looking at two parts of it. We're going to be looking at the cortex, and then we're going to be looking at the medulla. So cortex is this outer part of the adrenal gland, just as you had the cortex of the brain, which was the kind of a sausage-looking wrinkly part of the brain. And the medulla is the center part. And we're going to have more going on in the cortex. And I want to go through these with you. I'm just checking the size. Let's make it roughly similar. So cortex of the adrenal gland secretes mineralocorticoids. Mineralocorticoids play a role in the regulation of the electrolytes. So you can think of, for example, when you are exercising a lot and you lose a lot of fluids, you might end up then drinking a lot of water. But if you drink just water, that's not gonna work for you. What will happen? You will end up being very short of all the salts and electrolytes that you also need to have so that the fluids are balanced within our body, and also for the processes to take place. And you might actually end up with issues with the tonicity of the cells. So cells either gaining too much water or shrinking, depending on where the electrolyte balance is taking them. We'll talk about that in our review of the fluid balance of the body after the urinary system. Another one that I want to highlight is going to be our aldosterone. And what aldosterone does, it acts on the kidneys, plays a role in ATP production, and also with blood pressure regulation, with plasma regulation, and urination. So there's a lot going on there through the aldosterone that our adrenal cortex plays a role in. And I also want to mention as the last one, the glucocorticoids. Glucocorticoids really play a major role in the control of metabolism, control of stress or stress responses, and of course the glucose regulation as well. So those are the three important hormones or groups of hormones from the adrenal cortex. I think I can fit it underneath here. And I know that this might seem like a lot. Remember what I said about the endocrine system being the hardest part of this chapter. The other part that I wanted to discuss about the adrenal cortex was the medulla, and medulla secretes epinephrine and norepinephrine. And these two, of course, are gonna be involved with our fight or flight response regulation. So let's see if we can add a little note about that without getting too wordy. So I'm just gonna make a note here about that. So these two played a major role in regulation of that. That's really our adrenal cortex. I know that there's a lot going on there. The next one is going to be much easier. We're going to have a look of the kidneys. And if you feel that I move too quick from the adrenal cortex, we'll go back to that in a second. So I often speak about the function of the kidneys with students, and we don't always end up with the same conclusion about the main function of the kidneys. We tend to sometimes have a little bit of a different view that why kidneys are important for us. And it's not to say that one of us is right and the others are wrong. It's just to say that we can approach the study of kidneys a little bit of differently. So a lot of the time what I hear about the kidneys from the students is that, of course, we have kidneys to do the filtering of the blood, which allows us to produce urine. This is true, and this is an important function of the kidneys, but I wouldn't necessarily go as far as saying as it being the most important function of the kidneys. In my view, the most important function of the kidneys is the regulation of the blood pressure. So most blood pressure medications work through the kidneys. And if we have issues with blood pressure, it's likely that we will look at the kidneys, whether they have some involvement with these issues that we are facing. So I just wanted to add the kidneys there since the adrenal glands sit on top of those. So we get back to our right size of the diagram. And lastly, on this abdominal region that I want to highlight is going to be this gland here, which is going to be, of course, our pancreas. And just in the interest of saving a little bit of space, I did not force it there where we had the nodes from the adrenal gland spreading. So I'm going to write it underneath. So this will be all about looking at our pancreas. And if you have done any discussion of the pancreas in your previous studies, one thing that you might have heard is that we often think of pancreas as the kind of an odd one or the really cool one, depending on who you ask from, because pancreas has both endocrine and exocrine function. So the exocrine function of the pancreas is production of the pancreatic juice, which is one of the digestive juices that we produce that helps us to process the food stuff within the digestive system, especially in the small intestines. But that's not going to be our interest since we are talking about endocrine glands, which is all about hormones. The two hormones that are associated with the pancreas that we're going to be interested in are going to be glucagon and insulin. So glucagon and insulin both play a role in the regulation of the blood sugar. No, I didn't mean to do that. So let's add a note about that as well. That's what they do. They help us with the regulation of blood sugars. So that's the endocrine function of the pancreas. So the hormonal function that we're going to be interested in. Maintaining a right amount of the blood sugar through these two hormones. So that's going to be our pancreas. We've covered a lot, and we only have a couple of structures remained. You'll be glad to know. And these structures that I'm going to focus next are going to be, of course, the reproductive part of the reproductive systems. And for the females, the main reproductive organ is, of course, going to be the ovary. So let's have a look of what ovaries do and what hormones do we have there. So we often think, when we discuss about the ovaries, we think of them as the site where the egg cells are produced. That's true. Production of the egg cells is a very important function of the ovaries, but just as important is the production of the sex hormones. And the two hormones that I want to mention here are going to be our estrogen and our progesterone. So these are the two hormones produced by the ovaries. And again, about functions of both of these, we'll talk plenty more on our 2 chapters on the reproductive systems and when we look at the female reproductive system. But for now, all you need to know is that ovary, production of estrogen, and production of the progesterone. That's something that we want to note there. Let's have a look of the males. Well, I always say, I didn't mean to do that, that females in terms of their hormonal control are much more complex than males, which is true. So males are going to be super quick and easy to cover. We're going to be looking, of course, of the testes. And testes produced both the sperm, but the production of the sperm is not the only function. It's, of course, also the production of the hormones, which plays a role. And it's going to be for us, especially the testosterone, that we're interested in testes of the males as a hormone that gets produced. So we have pretty much, or we have all of these lines labeled that I had for this diagram, but there's one more hormone that I want to add to this. But why I'm not able to add it to any specific line or specific structure here is because this hormone is secreted from pretty much all over the body, wherever we find adipose tissue, so fat tissue. And we're going to be looking at leptin. So leptin is the hormone. I didn't really know. Maybe I should put it like this instead. So it's consistent of what we've had a look of before. And main function of the leptin is the control of appetite. So are you hungry or are you not hungry? We have done a lot of great, interesting experiments on mice that we've removed their production of the leptin, for example, or we blocked their receptors for leptin. And what will happen? They will just eat uncontrollably. They will eat actually until they burst. So they will have no control over when to stop the eating. So that's one thing that happens if we don't have the leptin receptors or leptin secreted. Leptin has been used on few occasions on individuals who have extremely severe weight gain because they do not either produce or they are not responsive to the leptin. So we can give leptin to these patients that don't produce it themselves, or we can help with the receptors of those of the leptin, and that can have a drastic effect that all of a sudden they're able to achieve what we consider normal ideal weight. So that's all the hormones that you need to know for this chapter. I realize we ran over. I really apologize for that. It is my really great goal that we do not run over, so I'm respectful of your time. But if you are wondering what you needed to get out of this chapter, it is really just simply this handout. What I want you to be able to do is to identify the key endocrine system glands and what they produce, whether it's the hormones that we have just discussed or whether it is the functions that they play role. So this would be a very handy handout to have around when you are preparing for the exam. I could see myself easily asking questions from this, for example, that can you name hormones from this gland, or can you match the hormones with proper glands which produce them. I didn't mean to move ahead there. So I really think that this one covers everything. So that's all I have for today. I really do appreciate you sticking around. Thank you, Daniel. And do not stress. Remember, we're going to go full review before the exam. This is pretty much all of the stuff that I had in terms of revising. I'm just going to jump to the other PowerPoint just to see quickly if there is anything that I missed, but I don't think that there is. It's similar reminders as I had last week about tutoring and so on. So I'll just show it through quickly for the sake of completedness. We got this far. We've completed a table that looks very similar to what I did with last year's class. So really, I'd say that this is the one to hold on to. I wanted to remind you that you can get tutoring help if you want through the Cranium Cafe, or you can let me know. I will help you as well. And if you have any questions, this is a great time to shoot them. And I think we covered everything that I really wanted to mention. So if you have any questions, feel free to shout out now. I will also stop recording if you want to ask those questions outside the recording. Otherwise, that's all I have for today. I really appreciate you sticking around. And please know that I always take that account when I assign the final grades, that who's been showing up and who might have been very active. So if you're on the border of 2 letters, I'll definitely look at that as well. So thank you. I hope you have a very good rest of the day. Let me know if you have any questions or any trouble. I'll stick around here, but that's it for today. So since we have no questions other than the people saying that it seems straightforward, I'm really glad it seems straightforward. We're gonna wrap up this session for today. And of course, we have another review session in the evening, but that's all that I have for the really brief review of the chapter on the endocrine system. You can find the full story, full details on the lecture videos for this module. So let me know if you have any questions. I know that the Connect is usually the one that students find the hardest or kind of most painful to get set up. I know that it might be a little bit of work, but once you get it up, it really gets you those points building up towards your final grade. So that's it for us for today's session on the endocrine system, and it wraps up our morning session for the week 2.